Hi students, in the last video I discussed nature of work example number 1. Today I am discussing example number 2 for nature of work. Example number 2. So the name of the example number 2 is if a body pulled on a rough horizontal road through a displacement yes displacement is S. Now see the diagram once. This is the rough horizontal road. This rough horizontal surface. I'm taking the one body. So in this case, the body having on this body some force is acting. First one is weight is acting downward, nothing but gravity force is downward. That is the downward. Second one is normal force is acting. That is upward. That is the end. Next one, if suppose I'm applying force on the block towards the horizontal direction means that is the F. Now this is the rough surface means the the contact between body and the rough surface some friction is happening. The friction is opposite to in this case in this diagram the friction is opposite to the force in this case that is to the a small f I consider in this case. Now the main intention of this example is we need to find out the work done. How much of work done is happening on this block in this case. The first point I am taking in this case, I will take the work done on the individual forces in this case. Total in this case four forces are acting. One is the weight, gravity force. Second one is the applied force towards the right direction. And third one is the normal reaction, it is the upward. And fourth one is the friction, it is towards the left to this diagram. First I will find out the work done on the first force, nothing but gravity. So work done by gravity. I am taking formula is for this one. W1 is equal to work done formula is force into displacement into cos theta. So here I forgot one point. In this case, what happened when you apply the force on this block toward the right direction, the block is displacing some displacement from the initial position to the final position. The displacement is S. Now in this case, applied force in this case gravity. In the place of F, I am taking in this case gravity force. That is the mg in this case. M into G, and displacement is nothing but in this case S into here cos theta. If you observe the displacement in this case toward the right direction, the block is moving toward the right direction, nothing but S vector, and the gravity is acting downward. So this is the gravity, that is the mg in this case. The angle between these two vectors in this case, displacement and mg, is 90 degrees. So I am taking in this case cos 90 degrees, that is equal to mg S into cos 90 value will be 0. That's why mgs into 0 is nothing but 0. So work done by gravity on this body is 0. So similarly I am taking the second one. I will take work done by applied force. Work done by applied force. Right. Again the formula is in this case W2 is equal to second force means second work done. Then formula is Fs cos theta in this case. So for applied force we are representing letter there in the diagram capital F only, that's why you have displacement also S only. But in this case see cos theta value how much? In this case the applied force toward the right direction is F and the block is moving toward the right direction only. So displacement also in the same direction. So force vector and displacement vector in the same direction means the angle between these two is 0 degrees. Then cos 0 degrees value is 1. F into S cos 0 value is 1. That's why this is the Fs. This is our work done number 2. So now this is the positive work done in this case. Positive work. Next similarly third one I am taking in this case. Work done by normal. So formula is this is the third force, that's why W3 is equal to Fs cos theta. So in the place of force I am taking what type of force acting in this case? Normal force. That's why normal force is n and displacement is s and cos theta I want. So in the diagram normal force acting is upward. One minute. Normal force is upward and displacement is the right side. The angle between these two is the 90 degrees. So cos 90 degrees. So then normal reaction into displacement into cos 90 will be 0. Then third work done W3 is equal to here 0. Then see the fourth one is work done by the frictional force. Work done by frictional force. So frictional force we are representing letter as a small f in this case. So this is the fourth work done. That's why W4 is equal to Fs cos theta. Here F is nothing but frictional force. In the place of capital F I am taking small f. Small f into S into cos theta. In this case this is the displacement toward the right direction and the frictional force acting opposite to the displacement. So here theta is equal to 180 degrees. So cos 180 degrees. So frictional force F into S into cos 180 value is minus 1. So total work done in this case, fourth work done is equal to minus F into S in this case. So this is the negative work done. So total now I found the work done 1, work done number 2, work done number 3 and work done number 3 I found it. Okay. So total how much of work done? Net work done is in this case. Net work done means total work done how much of is happening on this object means W is equal to W1 plus W2 plus W3 plus how many total 4 forces, that's why 4 work done. So that is equal to first work done once we have to see 0. Second one is force into displacement plus third work done is normal means 0 plus fourth work done is minus Fs. So that is equal to Fs minus small f. Yes. So finally W is equal to F. S is the common, capital F minus small f into S. This is the final work done. How much of work done is happening on this block means in this case W is equal to applied force minus frictional force into displacement. That's it. Thank you. Thank you so much.